Well, hey there, everyone. So, back down here at the Carrie furnaces, working on the 48 mil, and the 48 mil is actually inside this building. The crankshaft that was in the last video is actually right on the other side of that wall. This was what they called the blowing engine house for the blast furnace plant. Now, some of you may be wondering, well, what exactly is a blast furnace, and what are all these structures? So this video, I'm going to talk a little bit about what a blast furnace is, what Carrie furnaces are, and what this place really is. So the official name of this is the Carrie Furnaces National Historic Landmark, and is located in Swissvale, Pennsylvania, and Homestead is right across the river. Right to the left of me is Rankin and Braddock, and to the right, about 6 miles, is the Point of downtown Pittsburgh. It is a National Historic Landmark. It's a historical site that is open in the summer for tours and educational programs about the iron and steel industry and steelmaking in Pittsburgh. What they were able to do several years ago through the Rivers of Steel Heritage Corporation is to preserve this site, and this is the last remaining blast furnace plant in the area, except for the 2 furnaces that are now in operation over at U.S. Steel at the Edgar Thomson Works. And basically what it did, what a blast furnace would do, is take iron ore, which historically would have been brought down from Minnesota over the Great Lakes in the various, ore boats to one of the lake ports there on Lake Erie. For this mill, more likely it was Conneaut. Transloaded into rail cars, that ore brought down here and fed into the top of this furnace. And this is the furnace itself back here, and it's a tall cylindrical structure. The ore goes in at the top. Also coke, which is basically you take coal and you bake the impurities out of it, and you get this very light about 90% carbon material, and it goes in. That's the fuel. And along the bottom, that you have a ring that what they call a bustle pipe, and hot air comes in about 15 to 1700 degrees, and then is injected into the bottom of the furnace. And as that hot air goes in, it of course ignites and burns the coke, and a chemical reaction takes place which separates the oxygen out of the ore and then converts it back into iron, because iron ore is iron oxide, which is basically rust. It's a form of rust. It's when oxygen has combined with iron and created the ore. And so what you know of as rust is basically iron and oxygen recombining, converting itself back to its original state. So once that takes place, and that's a continual process, you continue to blow air in, you continue to feed materials into top. Every so many hours, you have several hundred tons worth of molten iron that collects in the bottom of the furnace, and then you tap it out into these things. They're called hot metal cars, or railroad cars that would carry molten iron in them. Tap out from the bottom of the furnace, through the tap hole there, into the car. Of course, this ladle is laying over on its side right now in the pouring position. And it has a refractory lining inside that would keep the metal of the car from melting away. And then this molten iron would then be taken across the river to the steelmaking furnaces and converted into steel to be made into ingots, and then blooms and slabs, and then rolled out into various structural shapes and flat shapes and plate and what have you. The interesting thing about the blast furnace process is that because they use that coke as a fuel, and the coke is mostly carbon, and iron has an affinity for carbon, so it likes to absorb it. That metal that comes out of the furnace is 3 to 4% of it is actually carbon. Well, steel has carbon probably in the, 0.18, 0.20, well under 1%. Well, you have to take that carbon back out of the metal to create the steel. So the steel making furnace mainly takes the carbon back out that was put in by the blast furnace. And it also allows you to refine how much carbon you want. Do you want anything else in there like nickel or cobalt or molybdenum or silicon or any of those other alloying elements to create the specific type of steel you're looking for. So as we stand here next to the cast house, and you can look up and see the very top there, the bleeders, just in case you had extra air pressure that had to be vented off. You can open the bleeders and vent that off. So I think what I'm going to do, since this place is, quite complicated, and it's not going to be able to get all of this in one video, is that I'm going to do a series of videos where I'm just going to walk around the site, and we'll just take a structure or a process or something of interest here and just focus on it. So there will be a series of videos that I will be making, and we're going to take basically an engineer's look at what a blast furnace is and how a blast furnace operates, and try to go through a lot of this metal work here and explain to the best of my ability what this stuff is and what it does, so that you have a better understanding of what this place is from an engineering perspective. Of course, as I mentioned earlier, this place is open during the summers. They have organized tours that you can come in here and you can walk around the site and look at all these structures in person, which I highly recommend you come to Pittsburgh to do. And if you've watched a few of these videos beforehand, then you might have a little bit of information about how this place works even before you set foot on the property, which is always good. So let's take a little walk down here along the cast house. So this track here would have had slag cars. So the one ingredient that I forgot to mention is limestone. So you have, as the Bruce Springsteen song says, iron ore, coke, and limestone. The limestone was a fluxing agent. So you had, your iron ore come in, which is mostly iron, but there's a little bit of dirt in there as well. And then your coke, well, it burns, but there's always a little ash residue from the coke. Well, something has to gather all that stuff up and get it out of the furnace. So what limestone does is when you charge it in, it also melts, but it's really sticky. And all those impurities just kind of stick into the molten limestone. And then you can open up a tap hole on the side of the furnace and then drain that off. And so all those impurities come out as slag. And blast furnace slag has been used for many years as a road building material and an aggregate, and also a valley filling material. There's a few valleys in this area that were completely filled in with slag. They put housing developments on. So that's what that track there was for. And then you can see the runners here for the slag. And then also we get a good view here of the skip hoist. This is how you get the materials to the top of the furnace. You got the skip hoist and skip cars that go up and down. You had the ore bridge, and the ore bridge would move the ore in the large storage yard called an ore yard. And then back there is a car dumper and the rail cars would come in, they would be flipped over, the ore dumped out into a transfer car, which would then take it down into the ore yard. So future videos, we're going to go over all this stuff in detail. This is just kind of giving you a general overview of the site. So let's take one last look up at number 6 furnace. So, all right, everyone. Well, I got some work to do on the 48 mil today. So, I'm going to try to do these maybe every week or every couple weeks. Another installment on our tour of Carrie furnaces. So, all right. Oh, and of course, Merry Christmas and a Happy New Year to y'all. Thanks for your support of my channel and all the projects and all the crazy stuff we've gotten ourselves into over the years. I really appreciate it. Thanks a lot.